93%. Not at one distance. Not on one day. 93% of everything that left the third interstellar object across its entire passage through the inner solar system was carbon dioxide. That is not a composition. That is a fuel load. This is the mass receipt, a Sentinel Network exclusive investigation. In 2005, a physicist at the University of Antioquia in Medellín, Colombia, asked a simple question. Stars have an evolutionary diagram. The Hertzsprung-Russell diagram traces a star's birth, life, and death. Every astronomy student learns it. Comets had nothing like it. Nobody could tell you how old a comet was or how many passes it had left. Ignacio Ferrin decided to fix that. It took him 5 years just to figure out what the axes should be. Stars emit their own light. They run on nuclear fusion. Comets do neither. Their brightness is reflected sunlight. The parameters that define stellar evolution do not apply. Ferrin had to invent new ones. He published 14 papers across 14 years. Each one refined the framework. The paper that dropped this week is version 20. Now the team. Ferrin is the lead author. Charles Triana operates a personal observatory in Boyacá, Colombia. His telescope is 10 inches of aperture. On December 31st, 2025, 61 days after its closest approach to the Sun, Triana stacked 79 images. He pulled a debris trail and a boulder out of the tail of an interstellar object from a 10-inch telescope in the Colombian highlands. Juliet Navas used the 1-meter Schmidt telescope at Venezuela's National Observatory. 83 days after its closest approach to the Sun, she captured a 6,565-kilometer jet emerging from the nucleus. 12 images. 2.5 minutes of total exposure. Venezuela's National Observatory, producing primary data on the third interstellar object in human history while operating through an economic crisis. Raul Melia runs his own observatory in Carlos Paz, Argentina. Another 10-inch telescope, Jose Garrido, is in Spain. The rest of the team is spread across Colombian universities. One is at a technical education institute. Nobody on this paper has access to Hubble. Nobody has JWST time. Nobody has a tenured position at an American or European research university with a 7-figure grant. In the publication gap, we documented what was not being published. Elsevier, the largest academic publisher on Earth, produced functionally 0 papers on 3i across their entire catalog. This paper is what the other side of that gap looks like. The work got done. It was not done by the people you would expect. It was done by a team that built their own tools and never needed the pipeline. Now the number. Every team that pointed an instrument at 3i found carbon dioxide. Everywhere. At every distance. In every wavelength. But nobody had done the math on the whole flight. Individual teams measure production rates at one distance on one day. That gives you a snapshot. Ferrin's team compiled every published measurement across the entire visible orbit and integrated. Total mass out, every molecule, start to finish. The answer is 93% carbon dioxide. Water was under 3%. Dust was under 4%. Carbon monoxide was a rounding error. The team had to use the density of dry ice for the nucleus mass calculation. Not as a convenience, because there is not enough of anything else in this object to change the number. You are not looking at a comet that happens to be rich in carbon dioxide. You are looking at a 2.8-kilometer block of dry ice with trace contaminants. That is a fuel load consistent with a machine burning through its tank. Now the disappearing act. There is a technique astronomers have used since 1984. You take the image, rotate it slightly, subtract the rotated copy. Anything lopsided survives. If the comet has any structure, the subtraction reveals it. On November 17, 2025, 18 days after perihelion eon, Melia pointed his 10-inch telescope at 3I and ran the filter. The comet vanished. No jets, no arcs, no structure of any kind. Every comet ever photographed has lumps, hot spots and cold spots, cracks that vent gas. When a lumpy object spins in sunlight, the outgassing is uneven. 3I had none of it. The sublimation was coming from everywhere, evenly, all at once, like a sphere dissolving in water. Then it changed. Later images show a debris trail, boulders, and a jet. Perfect symmetry through closest approach, falling apart on the way out. A normal comet does the opposite. There is one more anomaly. Between 120 and 45 days before its closest approach to the Sun, 3I/Atlas dropped to about 2% of its expected brightness. It stayed there for roughly 75 days. The shape of the dip looks like something passing in front of the object. If that is what happened, 3I is not one object. It is two. Ferrin could only see half the event. The interpretation is not confirmed. We flag it and move on. Now the clock. Every time a comet swings past a star, the heat strips away a layer. Ferrin calculated how thick that layer is for 3I. The answer is 59 meters. One pass, 59 meters gone. The nucleus is 1,400 meters across. Divide by 59 and you get 24. 24 more passes and there is nothing left. This object is burning through itself fast. On Ferrin's evolutionary diagram, the one he spent 20 years building, 3I lands in the extreme lower left, the region occupied by the iciest bodies with no dust mantle. Ferrin's conclusion is that 3I is a natural comet from another star system's Oort cloud. He is not proposing a machine. His data arrived at exactly the object we described. His interpretation did not. The data is what we publish. The reader can decide which explanation survives it. This paper was not produced by MIT or Caltech. It was produced by a 20-year research program at a public university in Medellín. Observational support came from a personal observatory in Argentina and a national observatory in Venezuela. When Ferrin needed a unit conversion in 2009, he emailed the scientist who invented the measurement. That scientist wrote back. Ferrin quotes the email 17 years later. That is how this science gets done. Here is the Sentinel Network's assessment. The 93% carbon dioxide composition, derived from orbit-integrated production rates across 97 papers, is the total fuel receipt. It supersedes every single snapshot ratio previously reported. The disappearing act, a coma so perfectly symmetric it vanishes under rotational filtering, remains unexplained by any standard cometary model. The provenance of this paper is as significant as its content. The suppression gradient does not stop science. It redirects it. The full briefing is on Substack. Link in the description. Keep looking up.